Hi everyone, welcome back to Synapse video series. I'm Haizhou Wang, a software engineer in Microsoft Windows Plus device data team, and today I will be sharing an introduction to causal inference and double machine learning. What is causal inference or causal analysis? If we think about it, it's really nothing new to us. In everyday life, we look to say if two things have either a association or a causal relationship, so we can drive decision making. For example, we may ask, do people who smoke often tend to have lung cancer, or do people who have higher education tend to have higher incomes? These examples are simple enough. So we know the former is causal and the latter is actually a association, not a causal relationship. But in most cases, it's not easy to find the causal effect, particularly when they are buried in noisy data or confounding variables. For example, in business setting, we wonder how big of impact does this new feature have on revenue or subscriptions. The gold standard for answering such question is A/B testing or randomized control trials. In some cases, randomized control trials are not feasible, and we have to fall back to observational data, and that's when causal inference is the next best option. Causal inference is a formal set of statistical tools that are used to identify the causal effect of a treatment on a measurable outcome, specifically when faced with confounders. There are a variety of causal inference methods like a matching method or diff, but today we will focus on machine learning-based causal inference technique DoubleML. The goal of DoubleML is to estimate the average treatment effect or the field not displayed in the equation. At a high level, it's a three-steps algorithm. In the first two steps, we make a prediction of treatment and outcome from the confounders using arbitrary models. In the last steps, we take the residue from the first two steps and use a linear model to predict the outcome model residue from the treatment model residue. The slope of this regression model can be interpreted as the estimated average treatment effect on the outcome. With the predictive power and the flexibility of machine learning model in DoubleML, it does not assume or depend on a particular model type and therefore make a minimal assumption about the function form of the model. It can also capture complex and nonlinear relationship between treatment outcome and confounders, which are more often found in real-world scenarios. However, one of the drawbacks of DoubleML is it assumes that all confounders have been observed and fed into the model. Now let's take a look at our implementation of DoubleML in Synapse. DoubleMLEstimator from its API, you can see why it's called DoubleML. User simply define two models, treatment model and the outcome model. And the DoubleMLEstimator will do the heavy lifting for you, completing as many iterations of ATE calculation as you want. In each iteration, it will resample the data and do cross-fitting with those three DoubleML steps we mentioned earlier. The fit function will return a DoubleML model that you can then get a ATE from, which will be the average of all the iterations result. The DoubleMLEstimator provides a scalable and accessible causal inference method that is integrated into SynapseML package. Some of the benefits of this solution include high scalability as it built as a Spark-based estimator, and it is easy to use in whichever language you are familiar with. Since SynapseML is a built-in component of Synapse Spark runtime, you can use DoubleMLEstimator in Synapse Workspace without any additional setup. And thanks to SynapseML AutoML feature, the API will do some featureization work for you on your data before fitting the model, such as encoding and imputation. Lastly, the consistent interface with EconML is easy to use for both data scientists and developers. Next, I will show a demo of how to use the DoubleMLEstimator in a real-world example with false data.
The demonstration will use a hypothetical example from a startup that sells software and wants to understand the effect of providing a discount incentive to its customers. Randomized experiments may not be feasible in this case, as the startup may not have the resources to conduct them or may not want to risk losing potential customers by offering no incentives. The startup has historical data on the investment made in discounts for each customer and their revenue, and wants to use this data to determine the best policy for maximizing return on investment. However, the data is biased because larger customers have historically received more incentives. DoubleML is well suited to address this problem by removing bias from the data. In this example, the DoubleMLEstimator will be used to estimate the treatment effect of the discount incentive, taking into account the bias in the data and providing the startup with an unbiased estimate of the return on investment. First, let's take a look at the data. The revenue column is the outcome column and the discount column represents whether the customer was given a discount, making this a binary treatment problem. The other columns are confounders representing customer features. Once we have loaded the data and set up the DoubleMLEstimator instance with the appropriate models, column names, and number of iterations, we can fit the data to the estimator and get the DoubleML model. Here we set the treatment model as logistic regression and the outcome model as linear regression, and set the number of iterations as 20 for demonstration purposes. From this DoubleML model, we can then obtain the average treatment effect or ATE and the confidence interval. For example, the ATE could be a numeric value such as 5102, which indicates that on average, customers who received a discount spent $5,102 more on software. The confidence interval will provide a range within which the true treatment effect is likely to fall, giving an estimate of the uncertainty in the ATE. With this information, the startup can make an informed decision about how to best use the discount incentive to maximize return on investment.
DoubleMLEstimator is currently available in the master branch of SynapseML. You can get started by visiting this GitHub link or scanning the QR code. Thank you very much for your time.